Hello everyone, this is Jordan. I'm from Zama, and today I will be talking about the concrete ML library that we developed. So this library is about allowing machine learning models to run on encrypted data to preserve privacy. Okay, let's deep dive in the code. So today I will be presenting and discussing a bit about what are the different modes to do the inference. As we've realized, it could be a bit confusing for users since a lot of things are hidden behind the scene. Okay, so let's, I've done like a plotting function that's not really useful to discuss, and I will use it later. So first thing we need to do is create a model. Second thing is create the dataset, and we are going to train the model, split it, train it, not plot it. Okay, so now we have the model. What we want to do is check its accuracy. So we are going to do a widespread clear, yes. And the first thing that will happen when you do just the prediction, and you don't care about over argument, it's going to be predicting in clear with this FHE equal disable. Great. So this is the first thing that you want to do. You want to check what's the accuracy in clear. So this is Python inference, no FHE, just the quantization that happens in concrete ML is applied. Right, once you are happy with that, you want to go to the FHE equivalent. So you want to see what's the impact of FHE. And here what you want to do is first compile. So you need to compile the model because now we are going to run both simulation and actual FHE execution. And simulation, so you can trigger it by calling the predict method with FHE equals simulate. And this is actually running FHE, but with insecure parameters, cryptographic parameters. So this allows you to see what's the impact of FHE without adding the FHE runtime that can be sometimes a bit long. Okay, so we are going to predict and compute the accuracy score, and we are going to straight go to the FHE equal execute as well. So here in FHE equals execute, we run the actual FHE, the secure one, with encryption, the run, and the decryption. Great, so we're going to run everything. Okay, so every time we run this, we should see the exact same accuracy for the three different models because the linear models are pretty good here. What we want to see actually is if FHE impact the accuracy. So this is why simulate was created because it's very fast. So here I'm going to force the PRR to the very extreme value. And what you will see is that now the accuracy is not exactly the same as the one in clear. And they are not exactly the same either between simulate and execute. And the reason for that is because there is some random that we cannot produce every time we run the FHE execution. But statistically, they should give the same error. And the last thing I wanted to show you is using a 2D plot. So I'm going to plot the decision boundary, so the decision of the model on a data set, a very small one, just to see what happens. So this is the clear prediction. You can see step functions that here represent the quantization artifacts. So here we have our blue points and our red points, and the model is trying to predict where are the red points and where are the blue points. It says that on the right part, it's the blue points, and the left part is the red points. And now if we look at the simulation, this is what you're going to see. You see that there are some parts that are a bit noisy. And actually everything around the decision boundary is a bit noisy. The model is not super sure about what should be the class here. And this is exactly what we want to see, because this trend should happen similarly in the actual FHE execution. And this is the actual FHE execution. So that's what we wanted to do with simulate. We wanted to reproduce what would happen in FHE, but very fast. And that's what we get. Okay, so that's it for me. If you have any question on this execution, don't hesitate to go to Discord or to the community forum where we try to answer as fast as possible. Thank you, everyone. See you.